panicked and crawled underneath the table where all the cables are and made a right mess of them. And I haven't had time to get them. But at least she didn't bite anything, so that's good. So we are looking at what we call line integrals. And I want to be, before we start doing some practice questions, show you that there are three essentially different kinds of questions, and they all look a little bit different, and they're all approached a little bit differently. So the first ones are the ones that look like this. And they could be X, Y, or Z. So let's do them 3D to be consistent. And they're going to have a DS at the end. Right, so you're going to get the ones that look like that. And when you get those guys, it's going to be from t equals 0 to t equals, I should say A to t equals B. Whatever the function happens to be. And then that weird square root guy, right? So dx by dt squared plus dy by dt squared plus dz by dt squared. And then you finish with a dt. And I was not clear that that is important, because if that says ds, you're going to do the ugly square root formula. Right. So call that number 1. Situation 2, I think it's better to give you some example of what situation 2 would look like. This might be x squared dy plus x plus y dx, you know, something like that. And when you do those ones, you're going to do the integral from t equals a to t equals b. And then you're just going to basically replace the x. Well, I need a curve for that, don't I? So let's suppose x was t and y was t cubed, just for argument's sake. Then this x squared would become t squared. And in this case, dx would be dt. And in this case, dy would be 3t squared dt. So x squared gets replaced by t's. The dy gets replaced by t's. The x gets replaced and the y gets replaced. And the dx also gets replaced. So basically your integral turns into this function, right? You'd, you know, multiply it out and then make it a single dt. And the third one that we haven't seen yet, because they come later on, is you're going to get questions that look like that. They have a name for that. Engineers have a name for this. Haven't a clue, it's gone. But anyway, there's a name for this if you want to become an engineer. And it's going to be t equals a to t equals b. And you're going to do f, and then you're going to multiply it by r dashed t dt. And this new guy called r dashed t is a vector, and he's made out of x dash t, y dash t, z dash t. So you're going to do a dot product, which means you're going to get an expression with t's dt. You're going to turn everybody into t's, so you're going to get an expression dt. You're going to turn everybody into t's, including an ugly square root part, dt. So all of them turn your integral into a single integral using dt, rather than an integral with x, y's, and z's. And so that's the three main guys. So question 3 and 4 are like him. So the one I'm choosing is question 3, I think. And the key to using the square root is a ds. The key to doing these guys is there'll be a dx, a dy involved in them. And the key to doing this one, it's kind of obvious, it'll say FDR, right? You won't be able to mistake that one from anyone else. So that's the guy that we're going to be doing. C is a line in 3D from the point 0, 0, 0 to the point 2, 3, 4. So there's a fair amount of stuff we have to do before we can even worry about, you know, this expression. First thing we're going to have to do is find what C is, right? We're going to find essentially its parametric form, right? Which if you write it this way, you could write it using that notation. Right, imagine that's 0, 0, 0. Imagine that guy there is 2, 3, 4, and you want to find the equation of the line joining 2 points, which by sheer coincidence is exactly where my Calc 3 student started right now. So way back in Calc 3, we found out how to find the equation, the parametric equation of a line joining 2 points together. The first thing I'm going to find is called the direction vector. And that's basically 2 take away 0, 3 take away 0, 4 take away 0, which in this case is dead easy. So far, so good. Secondly, we're going to choose a point. I'm going to choose the point. I'll call it P then. I'm going to choose my point to be the origin. Now you put them together. The X coordinate is 0 plus 2 times that guy. The Y is also 0 plus 3 times that guy. And the Z is 0 plus 4 times that guy. Are you comfortable about the equation, the parametric equation of this line is X equals 2t, Y equals 3t, and Z equals 4t? Are you comfortable where I got that? I know it's a while since you did it, but that's the equation of the line. So that's a preamble, that's stuff we need. Now we should be ready to put the package together. So this fella is going to be the integral from, for this line, right, joining P, right, 0, 0, 0, right, 0, 0, 0 to 2t, 3, 2, 3, 4, I need a t to start and I need a t to finish. What value of t do I start with? What value of t would give me 0, 0, 0? Agreed. So your mouth moving, 0. Be careful. What value of t gets me 2, 3, 4? So you're using this equation, but what value of t gets you 2, 3, 4? And it's not 2.
1.
You might have said if I didn't catch it.
1.
It's 1. So I know I'm going to go from t equals 0 to t equals 1. The x is going to be called 2t. The y is going to be called 3t. And the z is going to be called 4t. This bit here is the big ugly square root fella. We have dt. If I differentiate this guy, you get 2 and you square it. Differentiate this guy, you get 3 and you square it. And differentiate this guy, you get 4 and you square it. So it wasn't anywhere near as bad as it could have been. And this guy is 2t e to the 12t squared. And that's 1629. So that's a square root of 29. I'd probably pull out the 2 times the square root of 29 guy. And we would be left with that integral. Would you agree that's a U sub? And off you go and do your thing. That's where I'm stopping. So question 3 and question 4 are kind of like that. We know they're going to use the square root guy with that. What we had to do that was extra that we haven't done lately is find the equation of the line joining these 2 points. Are we okay with that kind of question now? Good. Keep that up and running for a little while. We've got some more examples here. We have this guy here. Now, do you notice that this guy here just has a dy, which is kind of nice because it means it's a short question. But couldn't it have so many dx's plus so many dy's, right? And when they look like that, right, we're essentially going to be doing this. Everybody gets turned into a t. They even have this fella here, but I'm going to have to build on him. If x is equal to 3t, then dx by dt is 3, and therefore dx is going to be 3 dt. Actually, I don't need that one, but I'm doing it for completeness. Y is 2t squared. So dy by dt is 4t, and that makes dy 4t dt. Now, in this question, that's actually the only one that I need, right? Because this only has a dy. But, you know, for completeness sake, I'm just going to show you all three. So z is this guy. dz by dt is that guy. And so dz equals 12t squared dt. Now we take this integral and we're going to go from 0 to 1. X is going to be 3t. Y is going to be 2t squared. E to the power of y, which is 2t squared, and a z, which is 4t cubed, times dy is going to be replaced by a 4t dt. So essentially, everything turns into t's, right? X, Y, Z's, dx's, dy's, dz's, whatever it might be, everything becomes a t of some sort. And I'll tidy it up a little bit. 3 times 2 times 4 gets me 24, which I'll just stick outside there. T squared and another t gets me t to the 4. And that guy gets me e t to the 5. And of course, since they have no imagination, that is also going to be a u sub, and off we go. Got a flow to it? Next one is kind of just like a grown-up version of that one. So let me show you. This is a version of question 6. Much nicer, right? X's, Y's, and Z's, and they can be in any order they like. It doesn't matter because they're all going to turn into T's anyway. Start with this guy. If I cut out the middle, man, is it okay to go straight to that without showing you the line that goes in the middle anymore? If we do this guy, cut out the middle, man, you get that one. This one, I'm not going to do that to. Too dangerous. If you cross multiply here, you get, you get t dz equals dt, which means that dz is 1 over t dt. And some people can go from there to there and they're quite comfortable. And essentially, don't you just differentiate this guy and stick a dt next to him? Differentiate this guy and stick a dt next to him. Differentiate this guy and stick in dt next to him. That's essentially what's going on. So we should have all the pieces now. It's going to be the integral from t equals 1 to 2. The y is going to be e to the t times e to the power of the natural log of t. And dz is going to be 1 over t dt. Okay. Plus the x is going to be, oh, be careful. Y is not e to the t. Y is 6t. I'm going to caught myself. Now, x is e to the t with a natural log of e to the t, and the dy is 6 dt. Take away 6t, and the x is e to the t dt. I hope I didn't make any other mistakes. So far, so good. Now, I can see an e to the log t, and I can also see a natural log of e to the t. And I think it'd be a good idea to write them down in a different form. What does e to the natural log of t get you? What is it?
Is it
You might
T?
be, it's t, right? E to the natural log of t is t. Oh, by the way, won't that t cancel with that one? So all you're left with is 6t. So that came out pretty nice. What is the natural log of e to the t? The
T.
natural t. So what you get is 6t e to the t. Take away 6t e to the t dt, and you get the guy who made this question, man or woman, was really cool. Would you look at how simple that integral is? Isn't this line integral a baby question? It's very simple, provided I haven't screwed up at least. But look at it original. Ugh, right? That horrible thing, line integral of that quite weird looking curve. The answer to that entire line integral is just this guy, which since it's so easy, I'll make it 3t squared. And that's 12 take away 3, so the answer's 9. I hope. We comfortable with that one? So these are examples where you would take the equation or the line integral and reduce everything into versions of t. Then we're done. Any questions before I show you the third type, which is these guys? Is this called the flux? Anybody in engineering, is flux a word? Does it mean something? I know it's a word, but does it mean in the engineering world? Okay, this might be called the flux. That word came into my head. Don't quote me on it. My memory's not great. So let's show you what a question would look like that has this formula. And they say, I'll write it down in full, evaluate the line integral. And it's the integral of f dr over some curve C. And then they tell you where C is given in a space curve format. And it's given as t squared, t cubed minus 2t. And you're also told that t goes from 0 to 2. Actually, they don't write it that way. But that's the way I always turn them into. They use that annoying IJK notation instead. But whatever a question does, if they write it like that, I immediately write it like that anyway. It just makes my life easier. I just understand positioning clearer than IJKs. Lots of reasons. Do you know my J's look like I's when I rush things? And sometimes if there's a missing term, I forget if it's the I, the J, the K that's missing. I make fewer mistakes when I write it this way. So there's the whole package. And so how does it work? Well, you have an integral from 0 to 2. That was the A to B bit. The vector, oh, I forgot to tell you who f is. The vector function, right, the vector field, f, x, y, z, this is in its full format. is x plus y squared, xz, and y plus z, right? Since I've kind of squashed it in, I'll put a bubble around it to make it a little bit more isolated. Right. So we are going to do FDR. F is this guy. And it's the derivative vector. dt, right? All these x, y's, and z's get turned into t's. And you get them by recognizing that this is the parametric version for x, this is the parametric value for y, and this is the parametric value for z. So all these x, y's, and z's are going to get replaced by these fields. So x is t squared plus y squared, which is what? T cubed squared, which is that guy. Xz is t squared times negative 2t, and y, which is that guy, plus z, which is that guy. So that's what f of xy looks like when you turn everybody into t's. Dot. R dashed of t. I know it's a while since you did Calc 3, but isn't that essentially the derivative of the space curve? So that guy gets you 2t, that guy gets you 3t squared, and that guy there gets you negative 2. Are you comfortable about the transfer of information, right? From the x, y, z's to this horrible mess, and the derivative, which is this guy, dt. Now, dot products, you go x component times x, y component times y, z component times z, all added up. So let's see what we get. I have t squared plus t to the 6 times 2t plus negative 2t cubed times 3t squared plus t cubed take away 2t times negative 2 dt. Well, it's messy, but it's doable. What I'm now going to do is just multiply all these things out and collect like terms and, do what we need to do. If we're lucky, there'll be a lot of cancelling, but I'm not guaranteeing it. So that's 2t cubed, 2t to the 7. That times that is negative 6t to the 5. Not much happened there. That's going to be negative 2t cubed plus 4t dt. And after all that hard work, really not much, except, I guess it's something, don't the t cubes cancel out? So we're going to be finding the integral from 0 to 2 of 2t to the 7, take away 6t to the 5, plus 4t dt. And that's where I'll stop. Would you agree it's just a boring Calc 2 question? Power rules everywhere. Anything about that question, or apart from the fact it's kind of long? Are you good with the process? How you find this line integral? Oops, there we go. Using that formula. Do another one. Okay. Chat. Who have I got? Doesn't matter where you go, you got tons of them. Let's do 10. Going to find that guy. Your vector function, your vector field, is sine x, comma, cosine y, comma, xz. The space curve for C, its format is t to the 4 negative t cubed in t, and the range of t is 0 to 1. Right, in this particular question, they break up all the steps. So they ask you to find out what that is in terms of t. So that's essentially question A. So it's going to be the sine of t to the 4, comma, the cosine of negative t cubed. And x times z is going to give me that times that, which I think is t to the 5. And then they ask us to find out that guy. And that guy is 4t cubed. That guy is negative 3t squared. And that guy is just 1. And then you put them together as a dot product. And so you're going to get that guy times that guy. So that's 4t cubed, the sine of t to the 4. Add this fella. Well, you end up with negative 3t squared, the cosine of negative t cubed. Add that times that is t to the 5. And our integral then becomes from 0 to 1 of this guy dt. That's quite a useful way, isn't it, to just set up your working? You know, just do the individual bits, and then once you're there, stick it inside an integral with a dt, and you're good to go. I'm going to stop at this point, except to say the usual kind of question for anything that looks weird. I'm picking on you today. Ready? Christian? This is a TIA question. What method will we use to integrate this guy?
U sub.
Correct. And another U sub, and then a power rule. So I think I made this rule up, but it actually seems to be working. When in doubt, do a U sub. Does that sound like a good plan for a lot of questions? If you can't think of what to do, try a U sub. I think the only time I would break that rule would be if there was a trig involved, in which case you may have to do something else. How are we going with these 3 types of line integrals, right? It's very algebraic. Here's a line integral, 3 different kinds, right? You get the ones with the ds, where you have to do that ugly square root bit. You get the ones that say dx, dy, in which case you turn everybody into t's. And then you've got these FDR versions, in which case, you know, there's a kind of process for them as well. Have you got any questions? Oh, Dylan, what's your question?
Oh, I had a question, but I figured it out. I was trying to find out where t to the 5th came from, but I figured it out.
It's so much better when you figure things out yourself.
Yeah.
It's kind of, yeah, I got it. Now I know what it's all about. Right, the next guy I'm going to show you, I have the visual, it's kind of visual, so I have to show you a picture of it. And this is question 11. We have a vector field. It's just 2-dimensional, right? So it's x squared, comma, xy. And the curve C is in fact a circle, x squared plus y squared equals 49. And they go and they ask you, well, part B, they ask you to figure out which one of these pictures it is, but that's not actually that bad. Don't you just plug that guy into the vector field, the 2D one, and you'll see it. I'm bad at guessing, so I'm not going to guess it. But where am I going with this? Yeah, the question doesn't look like you've got a question because there's no mention of any integral. You see that? It just says, find the work done by this force field on this particle moving around it, right? So can you imagine that the arrows are wind and the red thing is an aircraft that for no particular reason has decided that it's going to fly in a big circle, right, inside this windstorm. So you want to figure out how much work is going to be done, right? How much energy, I guess, would the jet or aircraft need to do that flight path? Because in some places, isn't the wind helping it? In other places, it's hurting it. In other places, it's not really doing one or the other, right? It's just having no main effect. So the question here is work done. That must be a line integral, or it wouldn't be in this section. So far, so good. And the line integral, if you want to do work done, is that guy, which I'm not so sure it's called flux anymore, but I think it is. Now, some of the information we've got, i.e. this guy, what we don't have yet, and we kind of need it, is how you do a circle. X squared plus y squared equals 49. So if you imagine, it would look like that. How do you do that circle in parametric form? Oh, and by the way, it says, if you read it, it says orientated in the clockwise direction. That was sneaky, almost missed that. If I said to you, isn't that polar? Would you agree circles are polar, right? If I ask you to do a minor change and use t instead of theta, would that be okay? So the x would be, what's that, 49, so what's that, 7 cos t, and the y would be 7 sin t. Does that seem reasonable? R cos theta, R sin theta. Are you with me so far? Right, if the circle was 100, wouldn't it be 10 cos t and 10 sin t? Right, that's essentially the x and y in polar form. So I've got my R of t. Problem with that is, what orientation is that going to generate? Because if I use it the way it's written right now, it's actually going to go the way it normally goes in trig. Don't you always go this way? But I don't want it to go this way. I want it to go that way. How could I make that happen?
Would it be from 0 to negative 2 pi?
What a cool way of doing it. Not the way I was going to do it, but I'm going to do it kind of similar, sort of, to what you said. Oh, that might have been what you meant. I think that's what you meant. That makes sense. Wouldn't that go around the circle the other way? Right. Now, we got our guys in. Anybody want to have a guess at how I was going to do it? Which is not as pretty as the way Maggie was going to do it. I was just going to switch the damn things around. I was just going to make the X sign and the Y cosine. Tweak it the other way. But I like your better, so I'm keeping it. So this fella is going to be turned into, what's that going to be? 49 cos squared t's, and xy is going to be turned into 49 sine t cosine t's. Okay, I'm cool with that. R dashed of t is going to be negative 7 sine of t, 7 cosine of t. Are we comfortable with that guy? Right. The vector field turned into t's, the derivative of the space curve in t's. Then I'm going to do the dot product. Leave a little bit of room here. So the dot product is going to be that guy times that guy. So it's going to be negative 7 sine of t, 49 cos squared of t, plus that guy times that guy. I'll do underneath because I don't have it. No, I'll try and squeeze it. I'm going to have 7 cosine t times 49 sine t cosine t. Okay, let's see if we can tidy it up in any way. If you multiply 7 and 49 together, you get a big number. I'm not sure what that number is, although I know it's 7 short of 350, so I do know what it is. It's that number, sine t cosine squared t. If you multiply them together, you get 343. And what do I get? I get, I think I get sine t cos squared t again. I'm worried about this. Oh, I shouldn't be. The little darlings. What does that become? If you take this guy and you add this guy, what do you get?
That just leave us with 0.
Yeah. I know what the integral for the line thing is. Going to be 0, because integrating 0 is going to get you 0. That is cool. Because what that is saying is that if you flew around this circle, right, the work done would be 0. Because in parts of the journey, you would be using up energy, but wouldn't you gain it in the other way? You know, like going up and coming down, you know, gravity hurts you and then gravity helps you, right? The net effect is 0. What a cool question. We even have a name for when that happens. If you have a force field where if an object goes round it and the net effect, right, the line integral is always 0, and this is just one example of it, but if it was always 0, right, no matter what, you know, pathway I took, you are looking at what's called a conservative field. They are very nice fields, right? Conservative fields, and it means this guy here is conservative. It's not to do with the curve, that's just an example. Conservative fields. We'll deal with conservative fields there. I wasn't expecting one there. That is just kind of cool. I like 0. It's a nice answer. Oh. The rest I'm not doing. The rest are videos you can watch. So let's finish off with just one I'll make. I can guarantee my question is not going to be anywhere near as elegant as that one, but I'm going to have a shot at it, right? So I'm going to have a vector field that is x, y squared, z cubed. So in my vector field, going up is a bad idea. Can you imagine all the vectors are going to be like a mountain shooting upwards? Like a volcano exploding something. And my curve C is going to be x squared plus y squared equals 1. That way I can keep this guy. and I'm just going to go round in the usual direction. So I can get away with just simply 1 times cosine t and 1 times sine t. And I will do my t from 0 to 2 pi. So I'm going anti-clockwise, which is called a positive orientation. So when you go clockwise, it's called a positive orientation. If you go around a circle, anti-clockwise direction, it's called a negative orientation. So I need two-dimensional guy. I apologize. That makes sense to have a circle, right? So it's just 2. Let's see what we have. My two-dimensional guy is x y squared, which is going to be cosine t sine squared t. Again, kind of happy with him. My r dashed of t is pretty boring. It's going to be sine t with a little negative in front of it and a positive cosine t. And I'll do the dot product of them. So that guy times that guy gets me negative sine t cosine t, plus that guy times that guy, which gives me cosine t sine squared t. So far, so good. And so when we want to find this line integral, which is the work done, at least in my story, it's the work done, it's going to be the integral from 0 to 2 pi of the dot product, which we've already calculated. Which is that guy. And I think that's a good point or place for me to stop. Couldn't you do this as a U sub? Who would your U sub be if you were doing a cosine t sine squared t combination? Only one of them works. Which U sub would you use? Cosine t sine squared t.
We want the u sub sine of t.
Yeah. And if you were doing negative sine t cosine t, there are actually 3 different ways to do this. Couldn't you use a U sub with cosine t as your U sub? Couldn't you do a U sub with sine t as your U sub? That would work. And couldn't you turn that into negative a half the sine of 2t using a trig identity and do it that way? So it don't matter, you're going to get the same answer. Actually, it doesn't matter how you're going to do it. That guy there's going to be 0 eventually. Don't know what that guy's going to be. It'd be kind of cool if it was 0, because that means I've got a conservative field. I'd like that, but I don't have time. Right, last name. Bye-bye. I'll hang about for any questions.